Hey, so welcome to the first episode of Programming Fundamentals. We'll be starting with the very basics of what a computer is, how it works, how the architecture works, and how we can build our own computer to all the way to programming big applications. A computer is basically a machine which performs calculations very fast and very accurate, and given a memory, it can even store that results. But computers are really dumb. You need to teach them everything from scratch. And that's what called as programming. But before that, let's look at types of knowledges. So there are two types of knowledges, declarative and imperative. Declarative are those which are factual information, which are unchangeable, and imperative are the processes or how-to or recipes that we can give to a computer. Computers mainly operate on imperative knowledge. Now, the question is what a recipe is. So a recipe is just like a cooking recipe, which we call in computer terms algorithms. So basically, they are sequence of simple steps with the control for process, and there is a way to tell them when to stop. So these mechanical machines called computers, they are of two types, fixed program and stored program. And the key difference is that fixed program are like a robot that can perform only one task. So it is programmed to do only one thing, and the program cannot be changed, just like a calculator. But in the case of a stored program computer, it stores the instructions but can even change it according to the need. So they are very flexible and they are more like the modern computers that we use. So this was about stored program and fixed program computers. Now, let's see how the basic architecture of a computer looks like. So as you can see, there's an input, there's something happening in the between, and there's an output. So let's take an analogy. You have a bunch of fruits, you put it inside a juicer, and you get the juice as the output. So that's basically how a computer works. We give it inputs, it goes inside the central processing unit, whether a control unit, the program counter, the ALU, arithmetic and the logic unit, which performs the primitive operations, and there's a memory unit where the things are stored. So all these three work together to give you an output based upon the input you give inside. Now let's look at the essential elements of a stored program computer. But why stored? Because it is flexible, it can store instructions and it even can change them. So it's more like a general purpose case. In an SPC, there are some sequences of stored instructions like the instruction fetch, decode, execute, and repeat. Let's look each one of them in detail. The first one is instruction fetch. So the computer's CPU fetches the next instruction from the memory. It is like, imagine a chess reading the next step from a recipe book. It's like that. Then the next part comes is to decode what's written there. So the CPU decodes the instruction to understand what actually to perform. So that's the decode. It's like the chef trying to understand what's written in that step before we can perform some of them. The next step is obviously execution to actually perform the task. So the CPU executes the instruction, which can involve any calculation, any data manipulation, or any other task. So it's like the chef reading the recipe out of the recipe book and starting to cook something. The final step is repeat. This is done again and again for each and every step. So the above three processes are repeated again for each and every new task. So basically, the sequences of stored instructions are at the very core of the computer program. This allows the computer to perform all the tasks, all the arithmetic operations, the complex data processing and running applications, everything. And this ability to store and execute different sequences of instruction, it is the exact same thing which makes the stored program computer so versatile and so capable. Move on to the primitives. The primitive instructions are the predefined set of instructions in a stored program computer. So the first one you can see is data movement. It's like the load, store, and move. So load basically loads data from the memory into the CPU register. Store, what it does is, it stores data from the CPU register into the memory, which is just the reverse of load. Moving data is like the copying data from one register to another. There can be input-output operations, or the input-output I/O instructions. So moving data between the memory and the input-output devices, like reading an input from a keyboard and writing the display to the monitor. The next one you can see is transfer. So move data between different registers or between memory and the register. This is used when you need to rearrange or kind of reorganize your data. The next ones are push and pop and exchange. Push and pop is used for managing stack data structures. So push basically adds data to the top of the stack and pop removes data from the top of the stack. This is a part of data structures and algorithms, so I'll cover in that part. And finally, the exchange. So it swaps the content of two CPU registers. It's like exchanging places between two items on a workspace. So there are two things and you swap them, like just reposition their places. The next thing I'm moving on to is logical operations. So there are basically three logical operations: AND, OR, and NOT. AND is a bitwise AND operation on binary data. There's a bitwise OR operation and a bitwise NOT operation. Moving to the next part, we got to the next part, this control flow, which controls the flow of the program, literally. There's a sequential control flow, a conditional, there are loops, there are branching, there is exception handling, and there's recursion. These are the most common control flows used in programs. Then the fourth predefined set of primitive instructions is input and output. So like reading input and writing output. So reading from the keyboard or from the mouse or some camera like webcam or sensor and writing it to, let's say, the monitor or printing something out from the printer. The next thing I can look at is simple test or basically comparison operators, which are used to compare different quantities. So the first one is the equality test or equality. Second is the inequality. Third is greater than, less than. There can be greater than, equal to, less than, and equal to. There are conditional tests and there are Boolean tests. So these are the main simple tests, out of which the first four can be categorized as comparison operators too. So finally, now I'm moving into the interpreter space. So interpreter is the real special program which performs this task or which actually handles the execution of each step in order. So its main roles are execution of the steps or the instructions that you give as a programmer. The second is to use test to change the flow of sequences of the programs. And the final is to stop when the work is done. That's it. That's interpreter. And each programming language has an interpreter which actually converts the human readable code into the machine language. So interpreter is kind of a translator which translates the human written code into the computer language. So that's it for today. Next I'll be covering primitives in the next video, which is coming out soon, probably. So see you on the episode 2. Bye.